Lesson 6. Other microorganisms. Viruses and parasites. Viruses are minute organic forms which seem to be intermediate between living cells and organic compounds. They are smaller than bacteria and are sometimes called filtrable viruses because they are so small that they can pass through the tiny pores of a porcelain filter which retain bacteria. They cannot be seen through a microscope, magnification of 1500 times, but can be seen through an electron microscope, magnification of 1,000,000 times. Very small. Viruses cause poliomyelitis, smallpox, measles, mumps, encephalitis, influenza, and the common cold. Viruses, like bacteria, are presumed to exist everywhere. Unlike bacteria, viruses cannot reproduce in the food. Food only serves as a reservoir and a transporting mechanism until it is ingested. Okay, so they only exist there. They don't multiply. Once viruses invade our body, they use our cells to duplicate themselves. Most often, the presence of viruses in food supply is an indication of contamination through human feces. Ugh. Food workers' poor personal hygiene, for instance, not washing hands thoroughly after using the toilet, is a major cause of these viral infections. The two most common types of viruses in the food industry are hepatitis A and noroviruses, previously known as Norwalk virus. Noroviruses have been recently implicated in various foodborne illness outbreaks involving cruise ships. Noroviruses are highly contagious and can spread very quickly. Hepatitis A virus can be fatal as it affects the liver. Parasites. Parasites are organisms that live in or on other organisms without benefiting the host organism. Parasites are not capable of living independently. The two most common parasites that affect the food industry include Trichinella spiralis, which is commonly associated with pork, and the round anisakid worm that is associated with many species of fish. With the growing interest in eating raw marinated fish such as sushi, sashimi, ceviche, etc., there is an increased risk of illnesses such as anisakiasis. One of the ways to control this illness is to freeze fish at minus 31 degrees Fahrenheit for 15 hours. Yeast. Yeast are one-celled organisms which are larger than bacteria. They too are found everywhere and require food, moisture, warmth, and air for proper growth. Unlike some bacteria, which live without air, yeast must have air in order to grow. They need sugar, but have the ability to change starch into sugar. When yeast act on sugar, the result is the formation of alcohol and carbon dioxide, CO2. In the baking industry, yeast is used to raised dough through the production of carbon dioxide, CO2. The alcohol is driven off by the heat of the oven. In wine production, the carbon dioxide gas bubbles off, leaving the alcohol. The amount of alcohol produced by yeasts is limited to 18%. Because yeasts are killed at this concentration of alcohol, yeast reproduce by budding, which is similar to binary fission when they divide into two. Generally, the methods described for destruction of bacteria will kill yeast as well. Yeast are not generally considered to be pathogenic or harmful, although a few of them do cause skin infections, yeast infections. Wild yeast, or those that get into a food by accident rather than by design of the food processor, cause food spoilage and decomposition of starch and sugar, and therefore are undesirable. Okay. Molds. Last but not least, molds. Molds are multicellular microscopic plants which become visible to the naked eye when growing in sufficient quantity. Mold colonies have definite colors: white, black, green, etc. They are larger than bacteria or yeast. Some molds are pathogenic, causing such diseases as athlete's foot, ringworm, and other skin diseases. However, moldy foods usually do not cause illness. In fact, molds are encouraged to grow in certain cheeses to produce a characteristic flavor. The structure of the mold consists of a root-like structure called the mycelium, a stem area filament called the hypha, and the spore sac called the sporangium. All molds reproduce by means of spores. Molds are the lowest form of life that have these specialized reproductive cells. Remember, the spore is what the bacteria use to encase itself until the conditions are right. Molds require moisture and air for growth and can grow on almost any organic matter, which does not necessarily have to be food. Molds do not require warmth and grow very well in refrigerators. Neither do molds require much moisture, although the more moisture present, the better they multiply. Methods of destruction for molds are similar to those required for bacteria. Heat, chemicals, and ultraviolet rays destroy mold spores as well as the molds. Refrigeration, I repeat, refrigeration does not necessarily retard their growth. They can grow in cooler temperatures. Certain chemicals act as mold inhibitors. Okay, calcium propionate, mycoban, is one used in making bread. This chemical, when used in the dough, retards the germination of mold spores, and bread, so treated, will remain mold-free for about 5 days. One of the most beneficial molds is the penicillium mold, from which penicillin, an antibiotic, is extracted. The discovery by Dr. Alexander Fleming of the mold's antibiotic properties opened up a whole field of research, and other antibiotic products from molds have been discovered. And that concludes chapter 6.